This is question 6 from the 2014 Matt. Alice plays a game 5 times with her friends Pam and Sam. So she's dumped Bob and whoever the other person was, Charlie. In each game, Alice chooses 2 integers, x and y, with x being between 1 and y, although it could be 1, it could be y. She whispers the sum to Sam and the product to Pam. So S for sum, P for product. Okay. So that neither knows what the other one was told. Sam and Pam then have to try and work out the numbers x and y. Sam and Pam are well-known expert logicians. Good for them. In the first game, Pam says, I know x and y. What can we deduce about the values of x and y? So Pam is the product person. So Pam has, multiply x and y together. So she's got a product and she knows what the answer is. So there's only one way to factorize it. Explain your answer, always the fun part of these. So if the product is, well, I don't know, uniquely defined, that's one way of putting it, then it must have only one way of being factorized. Only one way of factorization. So therefore we can say, if you can only have one way of factoring, x has got to be 1 then, isn't it? Because you can't have 2 primes, because if they were both, say, 2, you'd have 4. You could have 1 times 4 and 2 times 2. So we can't have that. So x equals 1, and then y, well, it could equal 1, or it could be a prime number. So that's okay. Although tougher start than usual on these questions. In the second game, Pam says, I don't know what x and y are. Sam then says, I know x and y. Suppose the sum is 4. So what are x and y? So, right, okay. So actually, I'll alternate colours on these. Explain your answer again. So if the sum is 4, so sum is 4, therefore Sam knows that we've got either 1, 3 or 2, 2. They're our only options, right? So that's what Sam knows. If it was, oh right, we got a 1 and a prime. Yeah, so if it were 1, 3, then Pam would know, because that is what we had in part I. Therefore, x equals 2, y equals 2. Okay, that's good. In the third game, Pam says, I don't know. Sam says, I don't know. Pam then says, I know. Suppose the product is 4. What are x and y? Right, so the product is 4. So product is 4. Therefore, Pam knows either. So we've got to have 1, 4 or 2, 2. It's got to be one of those. Right. So Sam then says he doesn't know on the next one. But we just had that in the previous part. So if it was 2, 2, he would know. Because, yeah, it's come out. Because if it was 2, 2, he would have been told that the sum was 4. In which case, he'd know that Pam didn't have the 1, 3, and he would have said. So it can't be that then. So if it were 2, 2, then Sam would know. Right, this is definitely, we're building up all the way through. You know, 2 has depended on 1. 3 has depended on 2. So I'm seeing this is going to be stretching all the way through. It's kind of standard in math questions anyway, that you always look to the previous part. But this is certainly even more so, I would say, in this one. So that was part I. Therefore, it's got to be, I forgot where I am now, it's got to be 1, 4. So x equals 1, y equals 4. Right, fourth game. In the fourth game, Pam says, I don't know. Sam says, I already knew that. He's showboating now. Right, so we got, she doesn't know. He already knew that. Now Pam knows. Suppose that the product is 8. Oh, my word. Right, so in 4. So the product is 8. So product is 8. Therefore, Pam knows that we've got either 1, 8 or 2, 4. We can't have anything else. So they're our only options. So that would mean that Sam says he already knew that. Okay. So he already knew. So he already knew based on what he's been told as a sum on these. So he's been told, right, so therefore Sam could have been told 9 or 6 for the sum. Right, so Sam is then saying he knows from those numbers that Pam doesn't already know. So what does that mean? What does that mean based on previous? So if it was 9, if he's been told that the sum is 9, then, well, Pam could be told all manner of things here, couldn't she? I mean, she could have, what could she have? Just wondering how this links back to the previous parts of the question, because it certainly isn't linking. We haven't got a 2, 2, a 1, 4, or 1, 3, or any of those. These are all bigger numbers. So, about the first part. So, y is 1 or a prime, and x is 1. Right, okay. So, yeah, so from part 1 then, if the sum is 1 more than a prime, or it's 2, then there's a possibility that Pam could know straight out. So if, yeah, we got this 6 here. The 6 is the interesting bit. If the sum were 6, then the product could have been, that's more to the point. I mean, it's not, because we know the product's 8. But if Sam had been told that the sum was 6, then he'd be thinking that Pam could have been told that the product was 5. So that, yeah, that's what we want. So we know then that the product is 8, so the sum must be 9. Right, so yeah, we know this then. Right, so, I mean, is that enough? We might want to put more words onto that. So let's just go through that again then. So the product is 8. So Pam knows that it's either 1 times 8 or 2 times 4. So based on those, Sam could have been told as a sum that it's either 9 or it's 6. If Sam had been told that it was 6, then he'd be thinking there was a possibility that Pam might have known. Pam could have known. So the fact that Pam didn't know, therefore the sum cannot be 6. Right, I'm now even forgetting where I am now. So we know that the sum has to be 9. So it's got to be 1 and 8. Therefore, x equals 1, y equals 8. Okay, that was significantly tougher than the previous 2 parts. Right, blank sheet. Finally, in the 5th game, Pam says, I don't know what x and y are. Sam then says, I don't know what x and y are. Pam then says, I don't know what x and y are. Sam then says he now knows. Good grief. Suppose the sum is 5. What are x and y? Right, so, right, this is full on, this is. So, sum is 5. So, Sam is told 5. So that means he then knows, therefore, we've got that X is either 1, 4, or it's 2, 3. So therefore, Pam is told the product of these things. So the product could be 4 or 6. Okay. What does that then mean? So Pam is then thinking, so this is Sam's point of view. That's Sam's point of view. So Sam's view. And then so Pam's view is if these products then, so we could have 1, 4, we could have 2, 2, we could have 2, 3, or we could have 1, 6. So that's Pam's view of it all. We've got those options. Okay. So we know, but I mean, we know it's not going to be one of these, but you know, it's still got either permutation of the 1, 4 or the 2, 3. So what happens then? So Pam says, I don't know what X and Y are. Well, of course she doesn't. She's got 4 options here. Well, actually, I say she's got 4 options. She's been told either 4 or 6. So could either of those limit down? Well, if it was 1, 4 or 2, 2, yeah, she doesn't know for 4 or 6 which one of those is going to be those permutations. It could be either of them. You've got 2 options for each one. So obviously Pam can't distinguish, right? So that's fine. So that's just a clear setup. So we can say statement 1, obviously Pam cannot distinguish. Obviously Pam cannot distinguish between options. Cannot distinguish between options. Right, so what then happens when Sam comes on the scene then? So in statement 2, Sam then says he doesn't know. And this has got to be giving us something useful out of all of this. It's got to be telling Pam something useful, isn't it? Or is it telling Sam something useful? Sam is thinking, right, so he's got that or that. That's Pam's view of the numbers. That's Sam's view of the numbers. I suppose he's also got his view of what Pam's thinking, because he would be thinking the same here of what Pam would be thinking. So how is this helping in there? So Sam's view is both of these things. This is his view of Pam's view. So if Pam was looking at one of those, then, right, this must link back to what we've already done, because there's too many options here and all the other parts have linked back. So Pam has said she doesn't know. Sam then says that he knows if the sum is 4, but he said that he doesn't know. Right, so that means the sum can't be 4. So that's good. Yeah, that fits. We're using this part. So the opening chain. If the sum were 4, then Sam would know, because that's what we did in part 2. Therefore, it's not that one. So we can rule out 2, 2. Right, that's good. Right, let's move on to statement 3. At least we've squeezed something out of statement 2. So in statement 3, this is now saying Pam again doesn't know what's going on. So what's happening there then? So we've gone back a third time. So this is part 3, isn't it? We've got I don't know, then Pam would know if the product were 4. So if products were 4, then Pam would know. Then Pam would know. because that's what we did in part 3. So we've ruled out that the product is 4, so the product is 6 then. Therefore, product is 6. In fact, I'm not sure we even needed this second bit, because the 4's getting ruled out anyway as being part of the product bit. So this bit is redundant, I think. I don't think I'm actually using that. Because, yeah, here we got, if the product is 4, then Pam would know. So therefore, the product is 6. So we've got, now it's come back to Sam. So in statement 4, Sam knows that the sum is 5, that sum equals 5, and the product equals 6. So the only way we can do that then is that x is 2 and y is 3. Wow. Yeah, and I don't think that didn't come up at all. I'm pretty sure I didn't have to use that, did I? Because we're just saying, yeah, if the product were 4, and the product being 4 rules out both of those. It means that the product is 6 and the sum is 5. Right, so yeah, that's statement 2. Okay, you need it to keep going, but I don't think it actually matters. I think we can just run it all off of part 3 into part 5. That was more difficult than the average question 6, I would say, on these papers. A very fun one. But yeah, a different style. We're not just going through the same if then else options on these that we had on previous papers. But I suppose it's good that they mix it up rather than just making it crank the handle every time you get one of these logic questions. So yeah, nice one. Again, it's been a nice paper all round so far, this, I think, in 14.